A very good afternoon, all of you. My name is Isha Sharma, and today I am going to discuss about the Unit 2 stack of a data structure. Coming to our next slide, that is stack. Basically, a stack is a linear data structure that follow a particular order in which operations are performed. The order may be last in, first out, or first in, last out. Basically, last in first out implies that the element that is inserted last comes out first only, right? And first in last out says that the element that is inserted first will become out last. Basically, the stack is a linear data structure that follows last in first out principle, where the last element is inserted first is to be popped out, which means both insertion and deletion of the operation happen at only one end. I hope you are understanding this principle of stack. Well, coming to the next slide, here we can see the diagram, like one example of stag, where here you can see the top element is C, that is a last inserted element. We can see this C is a last inserted element. So this last inserted element will be pop out first, and the element which is inserted uh, first in the stag will be pop out at last, right? So basically in push operation the recent element will be inserted at the top of the stack, and the recent element only pop out first. Okay. Hope this diagram helps you in understanding the operation of push and pop, right? Well, coming to the next slide, here I am explaining about the last in first out principle. Here in the last in first out principle, it means that the element is added to the stack in the first will be removed. The new element are always pop out, as I told you before in the diagram. So new element always pushed on the top, and removal means basically pop, right? Removing of element is also known as pop operation, है ना? Which is only happens only from the top of the stack. Basically, this ensures a strict order last in first out. Basically, if we see the real example of stag, have you ever seen the stag of plates in the parties, right? The last plate placed on the top, that is first one you pick up, है ना? आप लोगों ने plates देखी होगी when we visit to a party. There are stack of a plate, है ना? जो ऊपर रखी हुई प्लेट है, लोग उसी को सबसे पहले उठाते हैं। ऐसा तो नहीं करते कि लास्ट वाली प्लेट को हम पहले निकाल रहे हैं खींच के. सो द लास्ट प्लेट प्लेस्ड ऑन द टॉप इज फर्स्ट वन यू पिक अप, है ना? उसके बाद हमने शटल कॉक का बॉक्स देखा. हैव यू सीन द शटल कॉक बॉक्स? Shuttlecock box, basically in which the last shuttlecock is inserted first, which is taken out since both operation happen from the same end, from the top of the stack, right? If we talk about the basic terminologies, the top is a type of position most recently inserted element, where insertion means push and deletion means pop are always performed at the top, right? Size basically refers to the current number of the element present in the stack. Coming to the next slide, uh, basically, if I talk about the dynamic size stack, right? A dynamic size stack can grow, shrink automatically as needed. If the stack is full, its capacity extends to allow more elements. As elements are removed, memory usage can be shrink as well. Basically, we can represent stack by using linked list or dynamic array. एक्चुअली इट डिपेंड्स ऑन आवर यूसेज कि हम किस तरीके का स्टैक को हम इम्प्लीमेंट करना चाहते हैं। ठीक है, तो इट बेसिकली डिपेंड्स ऑन आवर डेटा, किस टाइप का डेटा को हम स्टोर करना चाहते हैं, एक्सेस करना चाहते हैं। सो देयर आर टू टाइप्स फ्रॉम which we can implement our stack: linked list and dynamic array. Right, in dynamic array, it resize automatically. Stack implementation, basically stack can be implemented using linked list or resizable array. As I already told you that as I already told you that basic operations of stack are push, pop, top, empty, and size. Basically, push is used to insert an element into the stack, and pop is used to remove an element from the stack. Top returns the top element of the stack, and empty returns it shows whether the stack is empty or not. Basically, size operations shows us the size of the stack, right? When we talk about the implementation of the stack, if the stack is implemented using array, then it is a linear data structure that follows last in first out principle. I hope that you know about the array. I have already explained in the previous videos about the array. So a stack using array is basically a linear data structure that follows last in first out manner. It can also be implemented using array by treating the end of the array as the top of the stack. It can be implemented using array, where we maintain an integer array to store elements, a variable capacity to represent maximum size of stack, a variable top of a top to track the index of top element. Basically, the initially top is equal to -1, which indicate empty stack, right? As you can see, this is the comparison between the fixed size stack and dynamic size stack. Here we can see the memory location of the fixed size and dynamic size. In the fixed size, it is fixed at the time of the stack creation, but while during the dynamic size, it grows, shrinks automatically as the element changes, right? Well, when I talk about the flexibility, basically its limits cannot exceed predefined capacity. Well, if I talk about the dynamic size, it is highly flexible, no predefined size limits. Performance is slightly faster on fixed size stack, resizing overhead, while in dynamic size it may have resize cost. Basically, in fixed size stack, we need to handle overflow, underflow manually. But in dynamic size, it is more convenient, no overflow options. Basically, in fixed size, it is useful when the maximum size is known in advance. But in the dynamic size, when sizes required are unknown, right? Okay, then thank you so much. I hope you understand the concept of stack. Thank you.